Today we're going to talk about binary search. We can use binary search when we are given an array that is sorted. So let's take this example here and say we're looking for an element with the value 98. We want to know what index that's at. Well, in order to find that, we could look through every element, go one by one, 2 isn't 98, 7 isn't, etc., and walk through the array in this way. However, then we're going to end up looking at n elements to get to element 98. And this isn't very efficient. That's O of n runtime, right? So instead we can use binary search and kind of cut our problem in half. So with binary search, what we're going to do is we're going to start at this element 42. And then we're going to say, okay, 42 is our midpoint. Is 42 98? It is not. But 98 is greater than 42. So we don't have to look at this left-hand side here. We already know we're not going to find our target value there. It's going to be in the second half. So then we take these three elements and we take the midpoint again. In this case, it will be 74. And we say, no, 74 is not 98. And then we compare again. Is 98 greater than or less than 74? Do we want the left or the right half of the array? And again, we say it is greater, and so we just look at the right half of the array, which in this case is just one element, 98, and that's our element. We found it. So here we're cutting the problem in half each time. We start with looking at the full array of 7 elements, and then we go to looking at 3, and then finally just 1. So that means that the efficiency of this is going to be log n, so log base 2 of n. Because we are cutting down the problem by a factor of 2 each time. And you can see that's much more efficient. And that's kind of how we tend to operate as humans. If we have this knowledge that something is sorted, we don't need to go and look through everything in between. Okay, so let's go ahead and code this up. Today I'm going to demo an iterative solution. There's also a common recursive solution as well for binary search. But in this one, let's go ahead and start by initializing our low and high values. So to start, the low value is going to be just 0, the first element of our array, and then the high value is going to be the end of the array here, so that's the length of the array, which is called my array, minus 1, because we index at 0. Great. So then what we want to do is kind of go through this array and shrink it and move to the left and to the right and adjust these high and low values to do that. So we're going to keep doing that as long as we don't end up with a low value that is higher than the high value. So while low is less than or equal to high, we're going to go through and calculate first the midpoint. So just doing an average, we know logically is going to be the high minus the low over 2. However, we need to offset by the low value as well. So remember in our example, we end up looking at this subarray here on the right. Well, if we just do high minus low, 6 minus 4, that's going to give us 2. 2 over 2 is 1, and that's going to tell us that our midpoint is now indexed at 1, but that's not true. We still have this original array. We're just kind of representing the subarray as this right piece here. And so we need to add that offset of 4 to do 4 plus 1 to give us the 5th element. So we're not creating new separate arrays. We're just keeping track of where our pointers are and offsetting them accordingly. So that's how we do that with the midpoint. Now that we have that index of the midpoint, if the value at that midpoint index is the target, then we can go ahead and return the value of the index of the midpoint, and we've found a solution. Another case could be that the value at the midpoint is less than the target. In that case, we know that if the target is in the array, it's going to fall in this right-hand part here, and we need to adjust our low value from the beginning of the list to the value of the midpoint plus 1. So here we're just going to change low to equal mid plus 1. The other case would be, so our else case, would be that the value at the midpoint is greater than the target, which would mean if the target exists in our array, it's going to fall in the left-hand side of the list. So instead of adjusting the low point stays where it is, and our high point gets changed to the midpoint -1. So high will equal mid -1. Great, and so eventually we'll get to a point where the low point will be greater than the high point if we don't find the value that we're looking for. And so we need to handle that as well. So once we've exhausted the while loop, if we never return here on line 8, we need to return something. So in this case, let's just return -1 because that is not an index. Okay, so in this test data we have here, we expect that the 98 will be found, right? Like in our example, 234 is not in the list, it's something greater. -2 is also not in the list, it's something less than what we have in the list. So I'm just trying to cover a few cases here. So let's run that and see if we get 6, -1, -1. Great, that's what we expect.